Okay, here's a video on C3, solving rational and polynomial equations. Okay, so rational ones look like this, where it's like a polynomial divided by a polynomial. So here we have a linear divided by a linear guy, and it's equal to 0. So we want to get x alone. But first, it's nice to get rid of a fraction. So I'm going to multiply both sides by x minus 1. So when I multiply the left side by x minus 1, those will just cancel out. And then when I multiply this side by x minus 1, 0 times x minus 1 will go away. So I'm left with x plus 4 equals 0. And isolating for x, I get x is equal to negative 4. Okay, so then this one's the same. I'm going to just multiply both sides by 7 so I can get rid of my fraction. And I'm left with 3x is equal to 0. And then if I divide both sides by 3, I'm left with x equals 0. Okay, this one's a little more crazy because it's got two fractions are equal to each other. So I'm still going to get rid of my fractions. So I'm going to multiply this side by x minus 1. So those will cancel out. I'm going to multiply this by x. Sorry. And then I'm going to try to get rid of this too. So I'm going to multiply both sides by x plus 4. So those will cancel out. And then I'm going to also multiply this side by x plus 4. Okay, so now what I've got is x plus 2 times x plus 4 is equal to 3x times x minus 1. And you'll notice I could have just cross-multiplied. It's cross-multiplying is like the trick. Okay, so then we just got to solve it. So we need to get the x's together. So we're going to have to expand all our brackets. So this guy, if I FOILed it, would become x squared plus 4 plus 2, which would be plus 6 plus 8. So I'm just expanding brackets like that. And then the other side will be 3x squared minus 3x. Okay, so now I'm noticing that this is a degree 2 function, so like a degree 2 polynomial, because I've got the x squared terms. I know I'm not going to be able to isolate x, because I can't combine the x squared. So I'm just going to put everything on the left side here, or the right side. Okay, so I'm actually going to move everything to the right side. So I'll have 0 equals 3x squared minus x squared minus 3x minus 6x minus 8. 3x, oh, I think that should be a squared, yeah. So 3x squared minus x squared is 2x squared. 3 minus 6 is minus 9x minus 8. Okay, so now I have to solve this. So this is a quadratic. So it looks like I could factor it. So two numbers that multiply to negative 18, or, oh my gosh, negative 16. And so multiplies to negative 16 and adds to negative 9. Possible? 4 times 2, 8 times 2, 16 times 1. I don't think that's possible. So you'd have to quadratic formula it. Okay, so if I was to quadratic formula it, I would do x is equal to negative b plus or minus b squared minus 4ac divided by 2a, and or you can plug it into your calculator if you can do that. I'm not going to keep going with this. I'm sorry, I don't have a calculator or anything. So you just solve this quadratic formula and you'll end up with 2 different roots for x. Okay, also, I'm just putting this in for Riley M, who said, sometimes there's ones like, let's just make one up, like x plus 2 over 3x equals 4. So sometimes when they're not equal to 0, say, so if you have a rational function like that, you really just solve them the same way. So I still want to get rid of my fraction. So I'm going to multiply both sides by 3x. These guys always cancel. So I'm left with x plus 2 equals 12x. And then I just still want to isolate x. So 2 is equal to 12x minus x. So 2 is equal to 11x. And then if I divide both sides by 11, I'm left with x is equal to 2 over 11. So your main goal is it's just solving an equation, really. And sometimes you have to quadratic formula it or factor it. But if you just have a degree of x, then you're just isolating x. So those are your rational guys for C3. Then we're moving on to our polynomial guys. So we have x to the 4 minus 2x cubed minus 7x minus 4x equals 0. So our goal here is we want to know what x equals, and often there'll be multiple values. So we just want to factor these and then set our brackets equal to 0. It's like a quadratic, but just a higher degree. It's a degree 4, this one. Okay, so I'm going to use to solve this. So I'm going to take the coefficients from these guys. So this coefficient is a 1. And then in front of my x cubed, I've got a negative 2. It's just my synthetic. I notice I don't have an x squared, so I have to put a 0 in there just as a placeholder for my x squared guys. Because these are my x4s, these are my x cubed, these are my x squared, then my x's, then my numbers. 2 x's. Maybe that was just supposed to be a 4. Or maybe the other one was supposed to be a squared. Ooh, I don't know. Hopefully this will work. Okay. Okay, so then I have a minus 7 and then a minus 4. Okay, so you know what? I missed a step. I don't even know what I'm going to divide this by. First, I have to find a factor. So using the factor theorem, if I sub a value in for x, then that value will be a root or a factor. Okay, so usually we try different multiples of 4. So like 1, 2, 4, things that I would try plus or minus 1, plus or minus 2, plus or minus 4. See if any of those are equal to 0. Okay, so if we try 1, we'll get 1 to the power of 4 is 1, minus 2 times 1 is 2, minus 7 times 1, minus 4. That's not going to equal 0. Okay, let's try negative 1. Negative 1 to the 4 is 1, minus 2 times negative 1, minus negative 1 minus 4 will be 1 plus 2 plus 7 minus 4. Also not going to be 0. Okay, so that doesn't work. Then we try 2. 2 to the power of 4 is 16. Minus 2 to the power of 3 is 8 times 2, 16. Minus 4, not going to work. So we try negative 2, so that'll still be 16. Then negative 8, so it'll be plus 16. Negative 2, but no. This is totally not going to work. What? Okay, you know what? I would redo this video, but I don't have time. So let's put this back to this. Maybe that's what it was supposed to be. I'm so sorry. Okay. Let's try this again. Alright, so for syntheticing, we got a 1, 4, a negative 2x cubed, minus 7x squared, minus 4. And what I'm going to do is, because I notice all of these terms have an x in them, I'm actually going to do my first step. I'm going to factor an x before I start. So then it would be x cubed minus x squared minus 7x minus 4 equals 0. Okay, I feel like that's good. So I factored out an x. Okay. Expression is 1x cubed minus 2x squared minus 7x minus 4. Okie doke. So let's see if we can find a factor now. Alright, so using the factor theorem, I'll do 1 minus 2 minus 7 minus 4. Okay, that's not going to work. Does this even work? Negative 1. Let's try negative 1. Minus 2 plus 7 minus 4. I think that works. Yes. Okay, so using the factor theorem, I found that when x is equal to negative 1, that makes my expression equal 0. Perfecto. So now I can put a negative 1 out here. Alright, first step, bring down the 1. Next step, multiply these outside guys. So negative 1 times 1, and put our answer up here, negative 1. Then the columns. So negative 2 plus negative 1 is negative 3. Then we multiply this times this, and we put our answer there. Yes. So then 3. Then we add the column.
Yes in your thing.
I know. So then negative 7 plus 3 is negative 4.
And now you say I know.
Negative 1 times 4 is positive 4, and then those add up to 0. Sweet.
Yeah, and then add us to 0, and then we're watching Peppa Pig.
Okay, so let's take this down.
So
we had x, and then this was our factor, so when we put it back in the brackets, it actually looks like that, x plus 1.
And then now it's time to put in this class.
Okay, then these become the coefficients, so that would be x, wait, 1 sec, Sydney. So that would be x squared minus 3x minus 4
and then all we have
equals 0.
Peppa Pig and
So just to check our degree, we got an x, and an x squared, which if you multiply those x's to give us x4. Okay, so we're in good shape. So next step, x, I'm just trying to factor this whole thing. I feel like I could factor this using a simple trinomial. So I have x minus 4, x plus 1.
It makes 1.
Sweet, I just factored my whole polynomial. It just took like, sorry.
And this is Sydney, I'm your daughter.
Okay, so next I'm going to actually solve it. So I'm going to set each bracket equal to 0.
Mommy's doing a speech.
Okay, so I set each one equal to 0, so I've determined that x equals 1, x negative 1, x equals 4, and negative 1 again. So that's how I solve a polynomial. I just factor it however I can, synthetic or long division. I might have to do that twice. Basically, I want to get it to this step. And I find a lot of people have a really messy solution. Like they do synthetic a bunch, but like it's super hard to follow. So I would make sure I rewrite this. Like the first step I did was I factored out an x. The next step I did was I syntheticed it by x minus 1, causing it to go here, where I now had x and then x plus 1, and then whatever my coefficients were, and then I took it. So try to be organized in your solution and show all your steps. So this is our final answer, and that solving just makes us find our roots or our x-intercepts. So now we've found our x-intercepts. Okay, also just one more thing. The remainder theorem, in case you need to know this for C3, it's the same as the factor theorem. It just tells you if you have a, like say we had x squared plus 3x minus 1, it just tells us that when we sub something in for x, like say we subbed in a 2 for x, it just tells us that whatever we get, so 4 plus 6 minus 1 equals 9, it tells us will be our remainder if we were to divide this, if we were to divide that by x minus 2, since I subbed in a 2, it tells us the remainder would be 9. So that's why when we use the factor theorem, we want the remainder to be 0. Okay, I hope this helped.